My name is Mike Amerlon, and I'm a program manager on the SharePoint Foundation team. And today I'm going to talk a bit about how you can develop solutions for SharePoint Server and SharePoint Foundation using the new client object model that's featured as part of SharePoint 2010. We live in a great time to be a web developer. A lot has evolved in the last 5 years to make your life as developers a lot easier. And first, there was Ajax, where you could do requests to a back-end server, and it came with it a lot of structures so that you could build objects and even frameworks for building great reusable components in JavaScript that run in easily in a multiple number of browsers. And so as a developer, you can build richer and richer applications. You can do things like implement a ribbon in JavaScript or implement a rich text editor in JavaScript. And you can build things on the web that look almost as good or even better than rich client applications, depending on what you're trying to build. And of course, rich internet technologies have also evolved quite a bit, Flash and Silverlight. With Silverlight, I'm sure we were probably all there 2 years ago with, in 2008 when Silverlight looked really cool but didn't even have a button class yet, right? And now they've come a long way in the last 2 years. You can do things like print, drag and drop from an operating system, right-click menu, lots of great things. But all these great technologies for building good user interfaces really don't matter as much if you can't get at the data that people want to use. And in a lot of cases, SharePoint 2010 has some data that maybe you want to get access to, documents, tasks, those types of things. Or it could host the data that you're interested in and give you a lot of free features, if you will. Things like, OK, RSS feeds and alerts and an out-of-the-box user interface for quickly editing items in a SharePoint site, leaving you to do the cool things inside of Silverlight or JavaScript. But to make this all work and to put these two things together, you need a good bridge. And so with SharePoint 2010, there's a couple of new major bridge technologies if you're building these client applications that talk to SharePoint. In the middle, we have our data platform, things like lists and sites and the standard site structure of SharePoint. And on the client, we have web services, as we did in 2007, for doing a lot of disparate types of operations against a back-end SharePoint store. But there's two new major technologies, client object model and REST-based APIs for accessing SharePoint data. And today, I'm going to cover the client APIs and how you can use those to build applications. A little bit later today at, I think it's 1:30, there will be a talk by Maxim Lukianoff who will be talking about REST and some of the other features there. But today, we'll focus on the client APIs. Now, client APIs versus REST give you really two different types of experiences for working with data. REST is really good for taking schema inside of your SharePoint site, products and orders and customers, and you can use tools like Visual Studio to connect to that and build rich representations, objects like a products object or an orders object, and do things like link queries to work very closely with the data that you have inside of your site. Client object model is a little bit more weakly typed. You'll be working with lists and list items, which can do more things against SharePoint. You can create sites, you can create lists. You can work with things like permissions or navigation. And so there's going to be times when you'll want to use REST APIs for simplicity and for getting things done very quickly, for fixed schemas. For more advanced scenarios, you might want to use the client APIs. And web services are still very relevant as well. There's a lot of operations that aren't exposed through REST or client APIs. For example, if you want to work with social data, taxonomy, you're going to want to use web services to get at those. So all three of these technologies are relevant for developers building on top of SharePoint 2010. Client APIs are a pretty cool foundation for doing lots of things, and that's what we'll talk through. So in today's session, I'll cover the basics of getting started with the client object model. You might have seen some earlier presentations that touched on the basics. I had one a couple days ago. We'll recover those basics fairly quickly and show you how it works. And then we'll build some scenarios using that. Now, a key concept of the client object model is doing very efficient queries from your client, whether it be a CLR application or Silverlight or JavaScript, to the back-end server. So being able to build efficient queries is really important for client object model and for your application. And the client object model has a number of tools that you can use to really do that. And then there's some advanced topics. You can actually do things like define exceptions and how exceptions get handled when you run scripts on the server. And also doing things like conditionally loading data based on, let's say, the user's permissions. And the final thing we have is a feature with the client object model for doing cross-site data access. So you may not have all of your application components on your SharePoint server. There's ways to get that data into the SharePoint server, but in addition, you can actually host applications on separate servers in Silverlight using the client APIs and have that work with people's SharePoint servers. So we'll talk about what that looks like. So when you work with the client object model, here's the basics of how it works. It's essentially a client-side library that wraps APIs that are exposed on the server. So if you're familiar with doing development on the SharePoint server, you're familiar with SP Web objects and SP List objects and SP List item objects, and those have direct equivalents in the client-side library. So you'll deal with a web object and a list object and a list item object. We got rid of the SP because we want to be more consistent with .NET, but other than that, the methods and the members and the properties and even the exceptions that get thrown are very consistent with what you see on the server, for better or for worse. In addition, this client library is compiled into 3 separate targets. There's a version of it available for JavaScript, and then there's 2 versions available, one for the core .NET CLR and one for the Silverlight CLR. So whether you're building an Office application that connects to SharePoint or whether you're building a very lightweight JavaScript web app, a lot of the tools and techniques will directly carry over. Now, as I mentioned, a very key goal of this API was to make it very efficient and to allow you to, first of all, very carefully structure the kind of data that you get back from a SharePoint server. But the other problem that you'll run into with, let's say, web services is a lot of times you'll have one web service which returns this set of data and another web service which returns a separate set of data, and you'll have to make 2 web service calls to go fetch and retrieve those to get, let's say, your application up and running. Well, with the client API, you as the developer on the client, can express exactly what you want to get all in one batch. So whether you want to get just the site and its title, or whether you want to get a site and the metadata for this list, and maybe the navigation infrastructure, you get to decide what the structure of that will be. The other thing about the client object model is we use it ourselves as well. So, for example, when you look at the new SharePoint document libraries, there's this feature where you can actually do bulk deletes and bulk checkouts, right? It's a commonly requested feature. And the way that works is it will actually use the client APIs in JavaScript to batch up that request and send it over to the server and have the server execute it. Tools like SharePoint Designer also use the client object model, so it's really robustly used throughout both Office products and on the web. So getting started with the client object model, as I mentioned, there's 3 main targets of it. There's one for the .NET CLR, and this is available to you in the 14/ISAPI folder. If you're familiar with SharePoint development, it's C, program files, common files, Microsoft shared, web server extensions /14, the standard SharePoint directory. And these are some DLLs that you can take and use for development. Later on, we'll be working on a redistributable for developers so that you can actually redistribute them and sort of include them in your applications. In the short term, the DLLs are available in the 14/ISAPI folder for working with them. For Silverlight DLLs, it's in a different directory. It's in 14/template/layout/client bin. But we're also looking forward to post-beta having an XAP that packages these all together so that if you're writing an application, you don't have to fold in 400 kilobytes of DLLs into your XAP project. You can just reference ours, and if it's already been downloaded, you don't have to have users pay that penalty twice of downloading the DLLs. So we'll have an XAP that you can reuse in your application and call remotely. And then finally, for JavaScript, we have an equivalent set of JavaScript files, also around 420, 450 kilobytes. And these can be dynamically loaded or dynamically instantiated in the page as you need them. So you don't want to necessarily just load them by default in your page. You want to wait until a user does something and then loads them up. And we have some tools for doing that as well. So this is pretty good. I mean, it's 400 kilobytes compared to, let's say, 15 megabytes for the entire SharePoint runtime. It's really the most of the weight of this infrastructure is in just defining all the sets of members and properties and all their various behaviors and how that maps to on the server. So when you work with the client object model, it's going to be a little bit different from some object models you might be familiar with. First and foremost, you can't just start instantiating objects and retrieving properties from them. If you want to get the title of a site, you can't just call web.title. You have to ask for it first. And so the way to ask for it is through a method on this client context object, which is the main object for working with the client object model, client context.load. And what this will do is it'll say, hey, client object model, I'm really interested in the default properties for this list object. Can you please enqueue that request for me? Now, you can actually batch multiple of these requests. So if you want to load 5 different objects, you would just make 5 separate client context.load calls. Nothing will actually get sent to the server at that point. It's just enqueuing that request. Then when you call client context.execute query, it will batch all of those requests and maybe any methods that you might have fired over to the server and execute all those things in a sequence and then return the results back to you in the client that you can develop against. So that's the basics of working with the client object model. Let's get started and look at some code for how to do this. So Over here, I have a very simple SharePoint site, and I've got some very simple applications to add to it. So what I've got is a Hello World Client Object Model ASPX page. And this is really a very basic SharePoint page. Doesn't even use a master page, doesn't have any of the standard SharePoint Chrome. I'm just referring to the Microsoft.SharePoint.WebPartPages.WebPartPage base class. Now, in the head, there's this control called the script link control. And what this will do is what you pass into it is the name of the JavaScript that you're interested in. And in this case, I'm interested in the JavaScript runtime. So I'm going to ask for sp.js. And this will pull in all of the dependencies needed to make sp.js work. You may have noticed that the JavaScript runtime actually has 3 script files. But I just need to add 1 script link to sp.js in my head to get it to work. Then what I have here is the registration of the ASP.NET Script Manager to make the AJAX fundamentals work. These JavaScript objects are based on the ASP.NET AJAX object infrastructure. I've got a simple button. And then what will happen is I'll do essentially the hello world of client object model. I'll instantiate a client context, which, again, central object for working with the client object model. I'll get the web object that's essentially the contextual site that this JavaScript is hosted within. And then I'll say, you know what, I want to retrieve all the default properties for that web. I want to get the web.title. And then I'll call execute query async, which will send this operation over to the server to process. Now, when that gets done, what I'm going to do is just a very simple taking the title of the site and adding plus JavaScript to the end of it. So I'm reading a property and then updating it. I'll commit that operation to the web, and then I'll commit that set of operations, setting the title and calling .update over to the server. So a very basic SharePoint page. So I've got this hosted in my site. It's got a very simple button. And when I press it, it will show a message box. And so when I go back to my home site, you can see that now the title of my site is Team Site plus JavaScript. So very basic, very simple, getting started to update that web property. Now, to show you something similar, I'm going to show you that equivalent example inside of Silverlight. So I've got a main page.xaml.cs. And you can see the code is almost nearly identical. I'm going to grab the client context.current. I'm going to grab the web object associated with that. I'll request the properties, and then I'll say send that over to the server. Again, I'll concatenate something to the title of the site, call web.update, call execute query async to make it go. Now, the interesting difference about Silverlight, and you're probably familiar with this if you've done some web service requests inside of Silverlight, is that user interface updates inside of Silverlight happen on a user interface thread. And when you do web requests and you do these asynchronous web requests, they're not going to come back to you on the user interface thread. And so for that reason, what you have to do is you have to reroute the request from your web service response thread, if you will, over to your user interface thread. And this is done through dispatcher.beginInvoke. So this is pretty common if you're working with web services in Silverlight, and client object model is no different in that regard. But once I'm done routing it over to the user interface thread, I just say done, and it's all done. So again, very simple demonstration. I've got a web part page with a Silverlight web part here that has just one big Silverlight button here. And when I click the button, it will show me an error show me a dialog box. And you can see that now the title of the site has been updated to say Team Site plus JavaScript plus Silverlight. So that's the basic hello world of working with the client object model. Now, for a more advanced example, I'm going to do some operations. So in this case, I'm not actually going to read any data from the SharePoint site. What I'll do is I'll have a very simple button. Again, this is just a very simple page. And what this button will do is it'll go create a list. And then in addition to that, it will go add a list item to that newly created list. And then it will go send that over to the server. So you can see I'm doing some very interesting things here. I'm setting the title. I'm saying, hey, base this on the announcements list template. And in addition, I'm saying, OK, now go add that list to the overall list of lists. And maybe what you can take away from this is I'm not actually retrieving any data first. I'm just saying, here's what I want to do. And I'm assuming that the web exists. And I'm assuming it's OK for me to go add a list. Just go execute this batch of operations on the server. So when we go back to this page, create list, I'm going to click my button. And it'll say done. And so when I go to my site, you can see that now there's a new library here called created from JavaScript. And there's a list item inside of it that says, with a body that says hello from JavaScript. So in one operation, one round trip from client to server, I've done something pretty cool. I've done a number of disparate things and fired some methods. Yep. So let's now take a look at how we can fold this into an application. So I've got a very simple flashcards application. You may be familiar with flashcards from grade school. When you wanted to drill for a test, you'd create these little 3x5 index cards. You'd write maybe a topic on the front and the answer on the back, and so you'd loop through them and try to study for a test. Maybe not the best educational method around, but anyway, it was at least common for me. And so you've got this very simple flashcard application where somebody has created some very simple flashcards for the capitals of states and what their answers are. And I can do a little bit of a drill mode here, and I can say, okay, what's the capital of Washington? Okay, well, it'll shuffle through, and what's the capital of Arizona? And I'll think about it, and then it'll come up and say, okay, the capital is Phoenix. But this is actually very static. This is just a web part hosted in this, a Silverlight XAP hosted in a web part on the site, and the actual flashcards themselves are hard-coded in. So let's go connect this to SharePoint and hook it up. So what I'll do is I'll just create a new custom list, and I will call this flashcards. So it's going to create that list in my site, and then I'll just create a couple of quick columns here. So one called question, which will be a single line of text, and another one called answer, which will be another single line of text. So very basic list. Okay, so now let's go modify this Silverlight project, which has the flashcards user interface. So I've actually got two projects in my list of overall projects I'm going to be demoing today. One is actually a SharePoint project that's built into Visual Studio 2010, and another is a Silverlight project which builds out in XAP. And Visual Studio has support for automatically taking the output of my Silverlight project and folding it into the SharePoint project when I hit F5. So it's pretty straightforward to take your XAPs, deploy them to your SharePoint server in a SharePoint solution package along with any other resources like a default .webpart file. And that's basically what I'm doing here. But let's go into our flashcard application here. And you can see this is a fairly straightforward .NET Silverlight type of application. I've got a list of flashcards. These are data structures that hold my flashcards. I've got some controls. I've got some various state variables for what's the current card I'm looking at. And then I've got my main constructor where I go build up all these data structures. And you can see what I've done here is I've just hard-coded in the default flashcards. But I want to pull these from the SharePoint list. So what I'll do is I'll just pull in some code that I'll explain. Now, first thing I need to do is I need to add some member variables for storing the SharePoint list that I'm coming from. So I want to have a list that has my flashcards SharePoint list and then the list of list items that have come back from SharePoint. It's almost a tongue twister. All right, so to get started with the Silverlight client object model, there's two DLLs I need to fold in. Again, these are in the CE program files, common files, Microsoft shared, web server extensions, 14 template layouts, client bin. We have our SDK is available as of yesterday, so this is all in the SDK. But for now, I'll just add the references to these like so. And then I'll fix these up to add the reference. OK, now they're turned green. So a little bit lower in, now I want to add my code that's going to load these flashcards from the SharePoint list. So I'll just replace this code here. So let's take a look at what this code does. What I do is I instantiate a client context, and again, I'm going to use client context.current, which essentially points to the site that this web part is hosted on. So I'm going to be working with the micam3/flashcards SharePoint site. I say I want to go retrieve the flashcards list, and I want to retrieve its basic metadata, things like its title and its description. And I use context.load here. The next thing I do is I say, OK, well, I also want to retrieve all the flashcards that are in that list. Now, to retrieve the actual list items in a list, you still do need to use camel queries. So this is an XML format that we have for specifying exactly how you want to retrieve items. You can use link to further filter down what gets returned from server to client, but you will need to use link in the client object model. So I say, OK, just create a default query to go fetch all the items for me. And then I enqueue this request as well into the context. And then I send these through execute query async. And again, I have to go pump over from the web service response thread over to the user interface thread. And once I'm done, I have this list item object. And for every list item I get back from the server, I'm going to build a flashcard data structure, set up the question and answer, and then I'm going to stash a pointer to that list item for future usage if I need to make updates. So that's how load works. Let's go implement a save button. Save button's a little bit passe, but for this simple example, they'll have to do. So what I'm going to add is some XAML for the save button to my toolbar, in a sense. like so. And then I will add the click behavior for that, which we'll take a look at once I paste it in. Okay. So the save behavior is pretty simple as well. So I'm going to loop over all the flashcard data structures. The flashcard data structures track whether they've been updated or not. And so for every flashcard, I'm going to take a list item, and I'll set the question and answer into it. I'll call update. And in the case where, for example, the flashcards are deleted, I'll just call a method on them called recycle. And I think this is probably the coolest line of code in this entire demo, because it shows you the power of working with SharePoint when you're working from Silverlight. You get behaviors like a recycle bin for free. So if somebody accidentally deletes all their flashcards, well, hey, it's a SharePoint recycle bin. You can just go to the recycle bin and restore them. So you get this really great benefit, new behaviors for free when you host your data in SharePoint. Okay, and then I'll send this batch over to the server. And so the cool thing about this is if I've actually updated 27 cards, that will all get batched as one web request from my Silverlight application to my client. So now I'll hit F5, and again, this will push it through a solution package into SharePoint and push all the features and all the various bits and pieces associated with it. So let's go back to our flashcards page, and now you'll see that the flashcards application says I've got no cards. I can add cards very quickly and say, okay, well, so what is the default object, the central object for the client object model? It's quizzing you already. It's the client context object, and I can add a couple more cards. So to commit changes, what do you call? And I'll say execute query. So I've added a couple cards here. And then I'll go click my save button. So this will take those changes over to the server. Probably would have been nice if I would have implemented a save as done, but keeping it simple. So when I go to my flashcards page, you'll see that now there's 2 list items here that came from my Silverlight application. And when I go back, of course, they're automatically restored for me. So this is just a very brief example of how you can take an existing Silverlight application in, I don't know, maybe that was about 30 lines of code, do basic CRUD, create, read, update, delete operations against your SharePoint site, against list items, using the client object model. Now, REST is also another option as well, and you can do more type-specific things. You don't have to use camel queries there, but if you want to do things like make sure that the list exists, you'd want to use the client object model for that. Okay. So that's the basics of working with the client object model to get started. And just to drive the point home, just reviewing those 2 samples I did for the very basic hello world, you can see that between C# and JavaScript, I'm just flipping between them, the code is pretty much the same. It uses the same methods and members and properties, really just accommodating for the different semantics of JavaScript versus C#. So let's talk a little bit about how client object model works under the cover so that you understand how it's built. So when you use client applications against SharePoint today, typically you call a web service. And what this means is as a developer, you have to, for example, if the web service takes XML, pack up and unpack the XML that's used on the server. Now with client object model, you get this DLL or this JavaScript file that you can reference in your client application. And so what will happen is when you call these various operations like context.load or list.create, it will batch those in a set of XML on the client object model. So it's batching all those operations. Oh, okay, they want to call list.add. Oh, okay, they want to call web.title. When you call execute query, it'll send that batch of XML over to a WCF-based service on the SharePoint server, client.svc, which will unpack that XML and run those operations directly against the SharePoint APIs. So it's one for one. If you say list.add, we're going to call spweb.list.add on the server. And if that throws an exception, we'll bubble that exception back out to you. The response gets returned back to the client, whether it's .NET CLR or whether it's actually JavaScript through JSON. This is done for efficiency and to really compact it, especially in the web case where you're using JavaScript. So then the results get sent back to you, and you can then access the objects and work with them. Now, the client object model supports a number of different objects for working in SharePoint. This is just the major objects. This is by no means all of the objects, but gives you at least the highlight of the important ones. So you get a site object, web object. Web essentially represents a SharePoint site, a little bit confusing, but a web represents a SharePoint site, and you can get all the objects inside of it, things like content types and lists, navigation structures. We have this new thing called custom actions, so you can add extensions to the ribbon. You can work with permissions, so you can, if you have the right to change permissions in the SharePoint site, you could give other people permissions. You can get the status of workflows, etc. Okay, now I've got 2 slides, which I call the bummer slides. this is what client object model doesn't do, and these are common questions that we get from people. And now that we understand what the client object model looks like. So the CSOM, the client-side object model, doesn't cover things like the user profile service or people or search. Excel has some really great facilities for calling into Excel via REST. Those aren't integrated with the CSOM, but they're pretty good REST protocols, so you'd want to use those. The publishing functionality, working with published pages inside of a SharePoint site, there's specific APIs for that that are not represented through the client object model. So not everything is represented. To some extent, we wanted to make sure that the runtime was small. I mean, at 400 kilobytes, it's on the border of being weighty for a web application. So we had to do a little bit of work to pick and choose things. But of course, over time, we'd like to add more of these APIs. There's also some limitations and some common questions we get back. So one of the questions that we get is, can I use the client object model on the server? Can I write some server-side code that uses the client object model to go instantiate things? And the answer there is, unfortunately, it might work on your developer machine, because chances are you're running your service accounts using your own username, and everything's all local, and there's only one server in the farm. And that actually might work, but in most farm-based deployments, web servers don't actually have a direct pipe back into themselves. They call back out through a load balancer. And that causes the request to lose a lot of its context. And so in those types of scenarios, the client object model really doesn't work unless you do an extensive amount of configuration to allow loopback scenarios. So typically, you wouldn't want to use the client object model on the server to just talk to the SharePoint APIs. You'd want to use the good old Microsoft.SharePoint SPWeb style thing there. Another common question is you do need to handle some of the synchronicity and update semantics of your client object model. It doesn't automatically poll. It doesn't automatically just go query every 10 seconds to say, has anything changed in the SharePoint site? For you Silverlight developers, it doesn't implement iNotify property changed as a case in point. So you won't get this automatic sort of, your user interface just updates over time as people add objects on the server. So you would have to do that. We do have operations for getting at the change log, which will enumerate all the changes that have happened in a site. There's no elevation of privilege capabilities, so if you want to run as another user, it's probably obvious as to why we don't allow that, but from a security perspective, we don't allow that to go remotely. Requests are throttled, so if you try to instantiate, let's say, 10 sites, that request will get denied because you're using a lot of request resources. And in addition, the overall size of the client OM request will be limited through our WCF channel to, I think it's going to be 64 kilobytes. So if you're enqueuing this request that works on, let's say, 100 objects or 1,000 objects, at that point, just the overall size of the request will grow, and we'll reject those requests as well. And the other thing that's a bit tricky is the .NET CLR has a synchronous method, execute query, for batching these operations, whereas Silverlight CLR and JavaScript are asynchronous. So the unfortunate thing about that is that if you're writing code that works in both places, you might have to adapt them a little bit. OK, so we talked a little bit about how you can retrieve data, but the real power of the client object model is you can very specifically target the data you want to retrieve. By default, when you say client context.load, it will fetch the default properties of an object, things like the title and the description and the date time. But in addition, you can use link to further target exactly what you retrieve, what properties and sub-objects to approve. It's probably best to just show what this looks like. So if you take the web object actually has dozens of properties. This is just a small subset. And when I call client context.load, what that will do is it will retrieve all of the simple properties associated with the web object, all the booleans and the integers and the strings and the date times and the GUIDs. It will go and retrieve all of those properties. But the web object also has some other rich objects associated with it, things like a root folder or things like the list of lists. And you need to explicitly request those. So if I want to get the list of lists, web.lists, I have to explicitly ask for it. The same thing for the root folder as well. So if I want the root folder, that object derives from client object. I have to say client context.load root folder. And if I want to get the lists object, I have to say client context.load web.lists. So these are the very basic semantics that you can use to get started with the client object model. It allows you to, in a coarse fashion, control exactly how you retrieve data from SharePoint. But you may also want to use link to sort of further pinpoint the kinds of queries you want to retrieve. Now, just as a very brief refresher, there's essentially two syntaxes for working with link. There's a query syntax where you can essentially express it in almost like a SQL-like way, T-SQL-like way, where you can say from list in client context.web.lists, give me all the lists that have a title defined for them, and then go fetch that. And that's very nice and straightforward. You get great IntelliSense. There's also a method syntax as well. And this is a bit more harder to parse in your mind, maybe. It uses essentially Lambda syntax for more specifically retrieving certain things based on the fields and whether they're hidden or filterable or not. And in addition, the client object model has essentially two modes of operation. You can essentially use the load method to sort of fill up the client context object with data. So if I say client context.load web.list, it will go retrieve all the lists in my site, and then anybody who ever calls that will be able to say client context.web.list, and they'll get the full set of lists. There's also a query mode where it won't fill the client context object. Instead, it will just return back to you the set of lists that you've retrieved. And so for this latter method, you can use both the query syntax and the method syntax of LINQ. For just filling out the client context object, you can only use the method syntax. All right, so it's probably best to start showing what this looks like. Just one last thing before that is, you can use various methods in your method query syntax to further filter things down. So there's a where method for choosing exactly which fields or which, how you want to retrieve objects based on the criteria of the object. So only retrieve lists that are of type document library, or only retrieve navigation nodes that have a title filled out for them, etc. You can use the include method to choose exactly which properties you want to get. Now, include is powerful because once you start using it, you explicitly own specifying all the properties of those objects you want to retrieve. So you can really very narrowly get exactly the data you want back. If you want to get both the default properties, per that diagram I showed you earlier, and then specify additional properties, you can use a method called include with default properties. And then finally, there's a take method for limiting the overall number of items you'll get back. OK, so now let's take a look at what this all looks like. OK, so in this case, I've got a very simple application that will just demonstrate the power of some of these queries. So let me stop this. And let me start up this is a Windows WinForms application. And this also uses the client object model. It doesn't do anything very interesting other than just demonstrate queries, but at least you can get the idea that you can use the client object model inside of a WinForms application as well. So I've got a query here that will essentially is a warm-up query that will retrieve all the lists in a site. So I go establish the context. I grab all the lists in my site, execute the query, and it'll tell me, OK, there's 17 lists in your site. And when I go back to the WinForms application, it's essentially listed all the titles of those lists and their identifier. But you can get more specific, and you can actually use queries to further narrow it down. So in this case, I'm going to use the query syntax to express a query that says, give me all the lists in the site that are actually visible for me. So don't show me all the galleries and the things that hold all the system files of a SharePoint site. Just give me the ones that users are actually using. So when I do this, I'm going to call load query, and I'll get back a pointer to this lists object. And so this is my way of sort of working with this data after the query is completed. Now, if I actually, that's not good. If I actually if I actually call list.count right now, it'll actually get a failure because I haven't actually retrieved them from the server yet. But I'll call execute.query. And so this will go and run over those. It'll go and run over and to do that particular query. So in this case, previously it returned 17 lists, and now it'll only return 11 lists because I said only give me the visible ones. So that's just a very basic query. Now, you can also reach in and pull in additional properties. So in this case, what I want to do is use the method syntax, and I want to load up all the lists in the site. But in addition to that, for every list that exists, I want to get the root folder property, and I want to get all the fields associated with this list. So I'm doing this like recursive query where I'm getting 17 lists, and for each list I'm going to get the 20 fields or the 50 fields associated with them. So I'm pulling in a lot of data, and I'm expressing that with this method syntax. I'm using include with default properties to say this is all in addition to the properties you would have normally retrieved had you called client context.load.context.web.list. OK. So now this is going to happen. And because there's so much metadata and things going on in a SharePoint site, it takes a while to display. But you can see here, now I've returned 17 lists. And for each list, I list out all the fields that were retrieved. And so I've got 17 lists, and it's retrieved about 50 fields per list. And all that data is now available for me to program against and work against and get the value of. So you can see exactly what's been retrieved. Now, the final query is a lot more pinpoint. It will specifically retrieve a list based on some criteria and specifically choose properties. So in this case, it gets a bit more complicated. What I'm going to do is say, OK, only give me the lists that are visible and available to users. And in addition, only give me lists that are of type document library. So I have a where clause here that says where list.baseType is equal to document library. And in addition, I'm using the include method here. So I'm explicitly specifying every single property I want to get back, the title and the ID and the name of the root folder. And then I'm going to say, for each list, go retrieve all of the fields that are not from the default base type of that list. So only return the ones that have essentially been added by a user or sort of visible to a user. And for each of those fields, I'm going to retrieve just the ID and the title, and then only give me the top 3 fields. So I'm making a very specific request, still getting lists and fields, but it's very targeted. And so in this case, what you'll see is it only brought back 5 lists, and then for each of those, it brought back the 3 sort of non-default base fields for those lists. So it's a much more targeted query. Now, when you look at this query, you might say, well, this is pretty complicated. I'll probably just use a simpler one and just get all the data back, and things will be good. But if you actually looked on the wire as to the size of these requests, this first query I did up here of all the lists and all the root folders and all the properties returns back 3 megabytes worth of data over the wire from server back to client. Whereas this more specific pinpointed query will only return 5K back from server to client. So when you think about web applications, 3 megabytes is almost untenable as a size to be sending over the wire from the server to the client. In addition, it puts a lot of load on the server to go fetch all those properties and retrieve them and aggregate them and send them back. So where possible, take advantage of these link semantics to sort of further narrow down your query. Now, the last thing I want to show is retrieving items. And so in this case, as I mentioned earlier, you do need to use Camel for retrieving those items. So in this case, I'm going to go retrieve the products list from a sort of a Northwind products list. And I'm going to specify a Camel query here in XML that says only give me the products that are of type beverages, that have a category of beverages. And then in addition, I'm going to do this link query to say, OK, you've retrieved all those results on the server. Further filter down what comes back from the server to the client and only give me 3 fields here. So I can use link to sort of further narrow down the query. Now, in general, it pays to move as much as you can into the Camel query because then the server will do less work. But you can use link in some cases to sort of usefully narrow it down in ways that you can express through Camel syntax. And then once this is done, I will just go add that to my text box. OK, so now I've returned just the 17 units out of about 80 in my list that are of type beverage, and I'll return the units in stock. So that's just very basically doing a query. OK, so now let's take an example, look at an example application for this written in JavaScript. So in SharePoint, they've done a lot of work to make it a lot more efficient and easy to use, try to keep the user in context, try to make things quick, avoid page refreshes. But I want to go one step further. I want to make it even more quick to use SharePoint. So what I've got is essentially this magic text box where I can type in various things into my magic text box, and then it'll automatically pull up the items for me. So let me show you what this looks like. So this is a 100% JavaScript solution. And what it did was essentially when the page loads, it added this text box into the upper right-hand corner. And now from here, what I can do is just type in some, for example, names of lists, and it'll give me like an autocomplete behavior so I can find it really quickly. So the nice thing about this is now I can jump between my lists very quickly. If I want to go to the site pages, I can say, oh, I want the site pages list. There's some out-of-the-box terms for things like settings. And in addition, I can also scan my navigation node. So if I want to go drill into that flashcards application, I can do that as well, and it'll take me to the flashcard subsite. If I want to go up a level, because I'm a nerd, I add .. as a semantic there. So you can really bounce around in your SharePoint site pretty quickly and easily, and that's a kind of a nice feature for more advanced users to make them more productive in using their SharePoint site. So how is this built? Well, essentially what this is again, JavaScript pushed up as a solution to SharePoint, registered as a feature, so when that feature gets turned on, and it does so automatically by Visual Studio, this text box gets extended, gets added. Now, in my case, I use jQuery to handle some of the logic around doing some queries and working with the document object model. But if I actually look at the script that I have myself, you'll see that really what I do is at the top, when things are initialized, I'm going to go find the element on the page that has this CSS class, the ribbon container in the upper row right. And then what I'm going to do is essentially just add a standard text box to that area. And then I'm going to handle the onKeyUp event. And I'm going to give it the style that's sort of consistent with the search box in SharePoint. And then I'm also going to put the focus on it so that as soon as I hit a page, I can just start typing, and it automatically starts working. Although sometimes, depending on the phase of the moon, the focus method doesn't work, so that's why I wrapped it in a try-catch loop. Now, the thing that's interesting and the thing that's nice about this is that's all it does in the standard case. It just adds a text box to the page. When I actually start hitting key presses, which maybe will only happen in 5% of the time that someone hits the page, at that point, it will do some work to load up the client object model and start fetching all that metadata back. So I've got some semantics here for handling up arrows and down arrows. But what you can see here is I've got this method here called ensure client object model loaded. As I mentioned, you want to be careful and judicious about when you load the client object model. It's 450 some odd K, so it's not a lightweight thing as far as JavaScript goes and as far as the web goes. It's very powerful, though. But in SharePoint, there's this method called SharePoint.scriptOnDemand, sp.sod.execute. And what this will do is it'll say, hey, SharePoint, go dynamically retrieve this file in all of its dependencies. So I say, OK, the file that I want is sp.js. And then there's a function here that will get called when that's ready and done, qw retrieve data. And notice I pass in a string because this function could have actually been defined in the JavaScript file I'm about to retrieve. So the function might not have been defined yet. But in this case, I've got it straight in line. Now, you might have thought to yourself, well, I was showing how you could do link queries based on, to further narrow down your query, but JavaScript doesn't have a link semantic. And so what we did there was we have this string format where you can essentially do the equivalent of link in JavaScript for including specific properties to pull down. So you can, again, do those very pinpoint queries inside of JavaScript as well. And so what you can see here is I'm going to grab all the lists, and I'm going to say, just give me these three properties, the title and the default view URL and the image URL of the list. And then I'm going to go grab the navigation structure and grab the title and the URL of the navigation nodes and the children of those navigation nodes as well. So I get essentially the top levels of the navigation structure of the SharePoint site. And I'm going to do an asynchronous query to retrieve those. Once that query is complete, I'm going to go loop over all of the lists in my web. And then for each of those lists, I'm going to build an internal data structure called a quick wheel link target, which is just a data structure I built in Ajax. And then as I type, I'm going to go sort of filter and adjust the autocomplete dialog based on the quick wheel link target data structures I've loaded. So this is just a very simple example of doing a query where I'm going to do pinpoint targeting, retrieve just the nav nodes in the list, and just about 3 properties per list. And it'll be a very efficient and quick thing to run inside of SharePoint. So that's just a sort of a quick extension of SharePoint using JavaScript, a little bit of jQuery. OK, so the final thing is we have some very advanced semantics. So let me just stop this real quick. OK. And we also have some very advanced semantics. Again, we're all about making these queries super efficient to use. And so a lot of times what you want to do is say, OK, I want to get this list. But if the list isn't created yet, I want to go and create that. And so to do that, typically you'd have to say, OK, does the list exist? Pull that result back to the client. Then say, oh, no, the list doesn't exist. So then send another request back to the server. And then create that list. And then from there, continue on your merry way. And so then every request has this sort of initial check request to say, does the list exist? Well, what we've provided are 2 different semantics for handling that. One is exception handling. So if you try to get the list on the server, but the list doesn't exist yet, that's going to throw an exception. So wouldn't it be nice to, for example, have a catch block so that on the server we can have some reactive steps that if the list doesn't exist, we'll go create it. And similarly, you can do conditional scoping. So you can say, only load data from this site if the user actually has permissions to retrieve them. Don't waste your time trying to retrieve the data if the user doesn't. So the best way to really demonstrate these is to really show them. It's clever, clever with a sort of a weird intonation. It's clever? Right. So let me go back to my handy-dandy client object model test application. And so here I've got a couple of behaviors for doing exception handling. So the way this works is I set up an exception handling scope. And so for the methods that get enqueued from here on out, they'll have a little bit of a flag that says, am I in the try-catch loop, or am I in the the try part, or the catch part, or the finally part? And so from here, what I'm going to do is I'm going to try to get this list called mySampleList. And if I can get the list, I'm going to set the description of the list to in the try block. And then I'll call foo-list.update to commit that change. Now, if the list doesn't exist, you'll get an exception on the server here because the list, again, doesn't exist. So there's some reactive methods here that will essentially go and create the list if it doesn't exist. And then there's code that will happen after all of that's done processing. OK. Now, you'll notice that this is just enqueuing operations on the client. So it's always going to go through the start try and the start catch and the start finally blocks here on the client, no matter what happens, because this is just enqueuing operations that will actually execute on the server. OK, so in this case, I'm just going to run this through. And when I go back to my SharePoint site, I go to my home, and I go to my all-site content, you'll see that the mySampleList was created, and it said, OK, the description of this is in the catch block, because it didn't exist, and it set that as the description. If I run this application a second time, it'll run through. Now this time, this call will succeed because the list now exists, and it'll set the description to in try block. And so when I go back to the page, you see that the description is now in try block. So you can do some pretty flexible behaviors, and again, all in one round trip. We're all about the efficiency of making these requests. Now the other thing that you can do is do conditional scoping. And in a similar mechanism, you essentially set up a scope that establishes a condition. So in this case, I'm going to check to say, only get me the web part gallery for the SharePoint site if the user actually has the permissions, manage lists, to work with it. And don't bother retrieving it if they don't, because there's no point. So in this case, I'll set up a conditional scope, and I'll use a link-like semantic to basically say, only get this if the user has this particular permission. Now, this can only be done for retrieval operations, .load. You can't call methods in these scopes that have side effects. So in this case, I'll say, OK, if this condition is true on the server, do that load operation, and then go execute the query. Now, in this case, I am the administrator of the site, so the condition succeeds, and I can now also show you the title of the list because the operation went through, and I can show you that the title of the list is web part gallery. But if I hadn't had permissions, it wouldn't have done any work there. It wouldn't have thrown an exception. It would have just continued on with the rest of the query. So that's a bit about, conditional scope. OK, so the final topic I want to go through is being able to delegate access to your, through the client object model across sites. So here's the problem. You've got a number of servers in your organization or maybe out in the world. And so a lot of times you have data and logic and semantics and web services on a web server, and then you've got SharePoint on another server. Now there's a number of tools for making those integrated. One of them is the business data catalog, the business connectivity services functionality, where you can pull in data from your other server into your SharePoint site and then work with it there. And you can do some pretty cool things with that. But maybe you actually want to keep all of your application logic and all of your data on one server, and you just want to sort of expose that into your SharePoint server. And in addition, you want to be able to mix and match the data between the two. I want my data on this server to be able to populate data on my SharePoint server and vice versa. So the idea would be, OK, we'll go ahead and host the XAP, the Silverlight application, on that application server and go do that. So in my case, I've got an HTTP SharePoint server, which is my SharePoint site. And as an example, I've got the Scrum application, maybe the central Scrum application for my company. And the Scrum server has all of the interesting data and logic and user interface. And SharePoint is where people have all their documents. And I want to really mix and match those two. So to do this, I might have an ASPX page on my SharePoint site. But that ASPX page might host a web part that's coming from HTTP Scrum. And so when that page loads up the XAP, it's actually served from HTTP Scrum/myscrum.xap. Now when you do that, Silverlight locks you, for security reasons, to only being able to call web services on HTTP Scrum. There's ways to work around that, but those have lots of interesting security implications. And so you need to be very careful with them. So in general, you can only call web services on HTTP Scrum. Now what this feature does is it will allow you to set up an infrastructure so that you can actually instantiate the page with a special token. And then your client object model that runs in your XAP will hand that token over to your HTTP Scrum server. And then the Scrum server can actually do operations against SharePoint on the user's behalf. So you get this best of both worlds. You can have your data on the Scrum server, things like what's the backlog and that type of infrastructure, but it can also work with your SharePoint site to do bits and pieces of data access. So there are some key concepts to making this all work. It's a little bit advanced, but there's some concepts you need to know. Now first, to make this all work, we have this concept of an application principal. So in that previous diagram, when HTTP Scrum calls into SharePoint, it needs to use a credential that's been declared an application principal. Now what this lets you do is actually assign rights and restrictions to that credential. So you can say, no matter what the incoming users request, I don't want HTTP Scrum to be able to create lists on my host SharePoint site. So you can create an application principal, only make that thing a contributor, and thereby constrain what HTTP Scrum can actually do against your SharePoint server. There's some XML for defining this relationship between servers that you'll have to provide. And then SharePoint has this concept of an external application provider. So we have a very default basic experience for working across these servers. But if you want to extend it and customize it and build a really nice experience for letting people add a Silverlight web part that sets all these types of relationships up automatically, you can do that. And then the final piece is that you have to have a request forwarder. So what this is a web handler or any sort of redirector that will take those client OM requests on your application server, HTTP Scrum, and then redirect them over to the SharePoint site. So those are the basics of the concepts. So let me show you how this works. So I've got my application site. You can think of this as HTTP Scrum. Now I'm actually hosting on a different port just to contain my demo on one machine. But when you see MikeM3:90, that's essentially our Scrum server. And this is a very basic Scrum server, but it's very simple. And the thing that's been exposed here is a web part that I can save to my desktop. So now I've got this web part so that if I'm on a SharePoint site, I can just add this into my SharePoint site and get started and working with that. So when I go back to my Northwind team site, I can go and edit this page and insert a web part. Now I'm going to go choose that web part file that I just saved from my server. Now in beta, this part has a bug, so it actually seems to require that I do this twice. So I'll do it twice. Okay, so now when I go back in, it should be there. Again, that's a bug in the beta. And then I'll hit save. So now what this is going to bring in is a Silverlight application that will actually work with the tasks list on this site to actually host all of that Scrum-related data. So when it pops in, it'll work with this tasks list over here to store all the various bits and pieces and tasks. Let me just, oh, there it goes. Okay, so now I can say, okay, we're working on this quick wheel project, and what I want to do is sort of add the ability to integrate with search. So I'll add a task for that. And this is just standard Silverlight. It uses the client object model to manipulate list items under the covers. So I'll say integrate search, like that. And this is a task that I can then say, okay, this is an in-progress task, or I can move it to my backlog. And under the covers, what's happening is it's actually manipulating items inside of my task list inside of this SharePoint site. But what you can see, if I just show you inside of Fiddler real quick, which is a great tool for debugging any sort of web request in a web application, you can see that when I actually move a task from in progress to the backlog, it's actually going to do a request over to MikeM3:90, our application server. It's going to call request_forwarder.ashx, an HTTP handler. It's going to redirect that request over to my SharePoint server. So that means I can host all the logic and the XAP on one server, and then I can also but hosted on a variety of different SharePoint servers as well. So I can really federate how that application works. The other nice thing is that I can say when this task is complete, I can mark it as done. And then the beauty of this is because it's hosted off my application server, MikeM3:90, when I go back, it should have, let me try that one more time. When I mark it as complete, it'll actually call a web service on my application server. Give it some time to complete before I navigate away. It should call a REST service on my application server that will then say, hey, somebody went ahead and marked this task as complete. So it'll add an announcement. So you can get these really great scenarios where you have data coming from multiple sites working together. And so it requires a little bit of setup. There's documentation in the SDK on this. It's called the Fluid Application Model in the SDK. We're working on the name a little bit. So if you're more interested in setting up this type of environment, you can do that as well. Okay, so with that, we've went over a lot of advanced concepts on working with the client object model, but I hope you take away that to get started with it, there's just 3 things you need to know. There's some DLLs in the directories, and it's pretty easy to get started building Silverlight applications that talk back to SharePoint. Think about that flashcards application. We released the beta SDK yesterday, and in the beta SDK, we've got a great set of documentation on how the client object model works. We've got 12 walkthroughs that you can go through that have essentially these basic hello world style examples that I went through. And you can really build some powerful applications using it. In the grand scheme of things, there are other options. There's web services and REST APIs, and there's a session later today to talk about those REST APIs and how to build custom web services, so I encourage you to visit that. And so that's really the client object model and how to build solutions with it in a brief nutshell. So with that, I appreciate any feedback you can give me on this presentation. I'm looking forward to seeing that, and if you have questions, I'll take them. Thanks a lot. Yeah, so if you have a question, if you have other questions, please use the microphones. Question? Yeah. So the question is, you push everything in a batch, and what happens if something fails in the middle of the batch? So that's a case in point where what we'll do is we'll return back the exception information and the details of where it failed in that batch. But yeah, at that point, the batch is stopped. And so if you had you had 10 operations and it failed at item number 5, you'll get the exception back for that. You'll essentially get the SP exception and that sort of detail back. And then 6 through 10 didn't happen. Now, you can use some of that exception handling information to have semantics around, okay, if it fails, but continue going on and do these other things. But by default, at times it can be even a little bit tricky to debug because you have to figure out, okay, why did this fail? And you have to sort of translate how these lines or codes are operating. So, but we will return the exception information back to. No, it's not transactional. You can imagine how this would be nice to sort of start doing transactional operations in the future, but none of this is transactional.
I had a question about security and port numbers and web traffic. For instance, our SharePoint site's open to the world, but I would maybe want to restrict this kind of traffic to, say, just on campus or something like that. Is this all happening over port 443, or is this happening some other backdoor way?
So whether you're using JavaScript or Silverlight, it all would happen over the web port that you come in on. And so JavaScript and Silverlight have, sort of both implement the rules of the web about how data access works, which means that you can do web requests back against the host server, so port 80 that you come in on, but you can't do web requests to, let's say, port 90, or you can't do requests from HTTP MICAM 3, port 80 to HTTP MICAM 4/80. So you can open that up with Silverlight. So if I own HTTP MICAM 4, I can place this file called client access policy to open it up. But by default, it's restricted to the point of origin. Questions? All right. I'll be up afterwards as well. So thanks a lot.